Hi everyone! Thanks for joining me for this next part of our gas giant series. And of course, this episode we are going to be looking at Uranus and what's to go with this particular planet. Now, just keep in mind we are pretty far away from home, from Earth at the moment. So we are getting to that part of the solar system where it's getting a bit cold, a bit dark, and whatnot. But after our encounter with the Daleks at Saturn, we've had to park the TARDIS on one of Uranus's moons, Titania, just to let Guide go through the system and make sure everything's okay. And of course, let the TARDIS sort of rejuvenate and recharge once again. We've arrived during a thunderstorm, which is quite pleasant and quite relaxing as well too. So Guide and I will spend as much time as we need to here on Titania while the TARDIS gets back to hopefully 100%, and then we can push forward to finishing the Gas Giant series very soon. Of course, we're about to obviously 3/4 of the way now, and we're almost there. We've got Neptune next, which will be nice and exciting to wrap up the series, and hopefully it all goes pretty smoothly for the rest of it as well too. So without further ado, why don't we just keep relaxing and now watch the next part and get some information about Uranus, shall we? Here we go.
The seventh planet from the Sun with the third largest diameter in our solar system, Uranus is very cold and windy. The ice giant is surrounded by 13 faint rings and 27 small moons as it rotates at a nearly 90-degree angle from the plane of its orbit. This unique tilt makes Uranus appear to spin sideways, orbiting the Sun like a rolling ball. The first planet found with the aid of a telescope, Uranus, was discovered in 1781 by astronomer William Herschel, although he originally thought it was either a comet or a star. It was 2 years later that the object was universally accepted as a new planet, in part because of observations by astronomer Johann Elliott Bode. Namesake. William Herschel tried unsuccessfully to name his discovery Georgium Sidus after King George III. Instead, the planet was named for Uranus, the Greek god of the sky, as suggested by Johann Bode. Potential for life. Uranus's environment is not conducive to life as we know it. The temperatures, pressures, and materials that characterize this planet are most likely too extreme and volatile for organisms to adapt to. Size and distance. With a radius of 25,362 kilometers, Uranus is 4 times wider than Earth. If Earth was the size of a nickel, Uranus would be about as big as a softball. From an average distance of 2.9 billion kilometers, Uranus is 19.8 astronomical units away from the Sun. 1 astronomical unit is the distance from the Sun to Earth. From this distance, it takes sunlight 2 hours and 40 minutes to travel from the Sun to Uranus. Orbit and rotation. 1 day on Uranus takes about 17 hours, the time it takes for Uranus to rotate or spin once. And makes a complete orbit around the Sun, a year in Uranian time, in about 84 Earth years, 30,687 Earth days. Uranus is the only planet whose equator is nearly at a right angle to its orbit, with a tilt of 97.77 degrees, possibly the result of a collision with an Earth-sized object long ago. This unique tilt causes the most extreme seasons in the solar system. For nearly a quarter of each Uranian year, the Sun shines directly over each pole, plunging the other half of the planet into a 21-year-long, dark winter. Uranus is also one of just 2 planets that rotate in the opposite direction than most of the planets. Venus is the other one, from east to west. Moons. Uranus has 27 known moons. While most of the satellites orbiting other planets take their names from Greek or Roman mythology, Uranus's moons are unique in being named for characters from the works of William Shakespeare and Alexander Pope. All of Uranus's inner moons appear to be roughly half water ice and half rock. The composition of the outer moons remains unknown, but they are likely captured asteroids. Rings. Uranus has 2 sets of rings. The inner system of 9 rings consists mostly of narrow, dark grey rings. There are 2 outer rings. The innermost one is reddish like dusty rings elsewhere in the solar system, and the outer ring is blue like Saturn's E-ring. In order of increasing distance from the planet, the rings are called zeta, 6, 5, 4, alpha, beta, eta, gamma, delta, lambda, epsilon, nu, and mu. Some of the larger rings are surrounded by belts of fine dust. Formation. Uranus took shape when the rest of the solar system formed about 4.5 billion years ago, when gravity pulled swirling gas and dust in to become this ice giant. Like its neighbor Neptune, Uranus likely formed closer to the Sun and moved to the outer solar system about 4 billion years ago, where it is the seventh planet from the Sun. Structure. Uranus is one of two ice giants in the outer solar system, the other is Neptune. Most, 80% or more, of the planet's mass is made up of a hot dense fluid of icy materials, water, methane, and ammonia, above a small rocky core. Near the core, it heats up to 4,982 degrees Celsius. Uranus is slightly larger in diameter than its neighbor Neptune, yet smaller in mass. It is the second least dense planet. Saturn is the least dense of all. Uranus gets its blue-green color from methane gas in the atmosphere. Sunlight passes through the atmosphere and is reflected back out by Uranus's cloud tops. Methane gas absorbs the red portion of the light, resulting in a blue-green color. Surface. As an ice giant, Uranus doesn't have a true surface. The planet is mostly swirling fluids. While a spacecraft would have nowhere to land on Uranus, it wouldn't be able to fly through its atmosphere unscathed either. The extreme pressures and temperatures would destroy a metal spacecraft. Magnetosphere. Uranus has an unusual, irregularly shaped magnetosphere. Magnetic fields are typically in alignment with a planet's rotation, but Uranus's magnetic field is tipped over. The magnetic axis is tilted nearly 60 degrees from the planet's axis of rotation and is also offset from the center of the planet by 1/3 of the planet's radius. Auroras on Uranus are not in line with the poles, like they are on Earth, Jupiter, and Saturn, due to the lopsided magnetic field. The magnetosphere tail behind Uranus opposite the Sun extends into space for millions of miles. Its magnetic field lines are twisted by Uranus's sideways rotation into a long corkscrew shape. Atmosphere. Uranus's atmosphere is mostly hydrogen and helium, with a small amount of methane and traces of water and ammonia. The methane gives Uranus its signature blue color. While Voyager 2 saw only a few discrete clouds, a great dark spot, and a small dark spot during its flyby in 1986, more recent observations reveal that Uranus exhibits dynamic clouds as it approaches equinox, including rapidly changing bright features. Uranus's planetary atmosphere, with a minimum temperature of -224.2 degrees Celsius, makes it even colder than Neptune in some places. Wind speeds can reach up to 900 km per hour on Uranus. Winds are retrograde at the equator, blowing in the reverse direction of the planet's rotation. But closer to the poles, winds shift to a prograde direction, flowing with Uranus's rotation.
Right. How good was that? A bit of information about Uranus you may not have known a lot about, so I certainly learnt a lot on this adventure of all the gas giants that I sort of didn't know about, which is really nice to know. And you can also rewatch these episodes at your own leisure whenever you wish to, whenever you've got some free time.
Wow!
Guide. What was that rumble just then?
I'm not sure. Want me to check it out?
Yeah, sounds good. Check it out, please.
My scan shows nothing out of the normal.
Really? Interesting. Alright, keep monitoring around the TARDIS outside and inside, just in case it happens again, because I don't want to get stuck against another arch enemy of the Doctors if possible. So just keep an eye out, please, will you?
Done!
Thank you very much. Cool. That was a bit of a scare, wasn't it? I wonder what that was. Alright, well, we're just going to sort of chill out for a while longer. We're going to sort of enjoy the quiet time, because it has been quite exciting to going through all the bits and pieces that we've learned already too. And just remember that once the Gas Giant series is done with Neptune, I will be going back to the classroom, because there is still 4 episodes to go with the series. We're going to be talking about other bits and pieces about space and whatnot. So it doesn't end with Neptune and the Gas Giant series. We will keep pushing on, and there will be another 4 episodes to go to conclude the series for the crazy facts about space and whatnot. Alright?
Damn!
Guys, happen again. Please do another scan. If you could, please.
I'm on it!
Thank you. I wonder what that was, Interesting. Alrighty. So what we're going to do is, we're going to stay put, because obviously I think we're quite safe here on Titania and whatnot. I don't think no one knows we're here, so it's nice and quiet. The TARDIS is getting back up to scratch, up to 80%, so we are almost at full capacity, which is great. So we've got power going back into the system, and things are recharging quite well too. So what we might do is just let everyone go and just say thank you very much for joining me for this part 3. And I'm glad that we well, hopefully that rumble wasn't anything in particular, but hopefully we don't encounter anything else, and we have a nice cruisy rest of the series, and keep going from there. So thanks very much for joining me. Hope you had a great time learning about Uranus and what's going on with that particular planet, and we'll catch you at Neptune. So once we're all done, we'll push forward and we'll see you soon. Alrighty, thanks very much. See ya, bye!